you can't use a. All right. Yep. So I've got both these kind of set of like practice quiz or exam problems. We'll kind of work through, whichever you guys have specific questions. Otherwise, I'll kind of pick and choose a few. I'll talk a little bit about the exam here to start class out. So it'll be, have it kind of written. I think originally I was saying I was going to do some short answers on there. I have a slightly different idea for what I'm going to do. So I had some short answer questions that I basically just turned into multiple choice, which I actually think makes it a little easier in that when you're calculating something that's open-ended, at least now I'm giving you some potential answers. And some of those potential answers may be, if you understand the principles, pretty easy for you to rule out. Right? So it actually makes it a little bit easier to move open-ended. Also, potentially have an idea for something that I might kind of do after the exam, but I want to save kind of something more like a short answer question for. So it'll be 25 multiple choice questions, right? So time might be a little bit of an issue, right? You've gone through these two sets of practice quiz problems, and you're feeling pretty comfortable with those. Time probably won't be an issue, but if you're having a little bit more difficulty, try to make sure that you're not spending too much time on a problem that you get stuck on, right? Maybe kind of work through it and then come back. I'll also tell you in advance, since 20 people got I got a lot, quite a few people here. So those of you here, you can already expect that there will be one bonus question. So basically, there's 26 questions, but I'm only going to grade you out of 25. So 104 points possible for you to get, but I'm going to grade it out of 100. So get them all right, you're actually going to end up with above 100%. Okay? So it's kind of like you get a freebie, you can miss one problem for free and still get 100. Okay? I would suggest making sure you have a calculator that you're comfortable using. Bring that. I'll have extra paper. The only formula, so I won't hand out a formula sheet. I'll write it out on the board. The only thing that I think, I don't necessarily want to expect you to kind of memorize is if we're kind of coming up with an elasticity measure. We'll say for demand, actually demand. I'll write this up here on the board. And really, it's kind of, could be anything. For, maybe I want elasticity for income, right? Instead of price, I would do income here. But I'll kind of write this out to remind you that midpoint method is really kind of just taking the difference between the two values and dividing it by the average of those two values, right? So to the percent change in quantity demanded, I look for the change in quantity, and then divide it by the average between those two quantity points. And then here, I would look for the change in price divided by, screw that up, average price, right? So I'll kind of have this written up on the board, right? You could replace price with income, you could replace quantity demanded with quantity supplied, but at least kind of giving you this format of how we use that midpoint method to calculate elasticity, or how to calculate these individual percentage points. This is as important as lots of other things. Any questions from just about the procedure, the logistics of the exam before we kind of jump into some problems here? Okay. Does anybody have any specific problems I want to work through?
I have a quick question. I know you said for the multiple choice that we can do like partial credit if we don't get the right answer. If we or not the multiple choice, the short answer.
Yeah.
So if we show our work on the multiple choice and get the wrong answer, but it's like the right steps, do we get partial credit?
Yeah, so you don't have to show any work. So it's either you get it right or you don't, right? So it sounds like a little bit harsh, but there's advantages and disadvantages to multiple choice and short answer. And one of the advantages I think that outweighs the disadvantage of that you can't get partial credit is that you at least have some options, and knowing the principles, even if it makes it less likely that a common kind of mistake would then lose you points, right? You can quickly identify some things that are definitely not correct answers. But yeah, you don't have to show your work because I'm not going to give any partial credit. I might do some stuff for after the exam that I do some stuff like that for. Any other questions before I? So any specific questions that you're confused, want to see work through on either one of these kind of sample quiz practice exam problem sets? Huh? Yeah, so this kind of goes back to a really old concept, right? So you've got an individual who can go golfing, watch a movie, take a nap. He values these, activities at different values. So golfing 36, movie $23, and napping is 62. So what would the opportunity cost be if they go golfing? So opportunity cost was the idea of when you choose to do something, right? Like even if, say here, it cost him $0 to actually go on this golf course and golf. Right? There's still cost to choosing that activity because you're using that time to not do something else. So your opportunity cost is going to be whatever you valued the highest that you could have done other than the activity you chose. So what was the benefit essentially that you were missing out on? So here, if the individual chooses to go golfing, right? If we look at, well, if I use that same time to instead nap, I would have actually been, that would have valued the marginal benefit to me of $62. So that's what I'm missing out of, right? By choosing to go golfing, the activity that I'm not doing was actually worth $62 to me. So that's the opportunity cost of going golfing. Now, let's say that instead of $36, he valued going golfing at, I don't know, $360. Right? Well, then that would make sense because the activity he was choosing, right, even though he has this additional cost of what he's missing out on, right, this was his opportunity cost because it was what he could have done with that time instead of going golfing to napped and then he valued it at $60, so he's missing out on that benefit. Well, at least here, he would still have a positive net benefit, right? So even if you factor in the opportunity cost, right, his benefit to going golfing would still be positive. However, at that price of 36, is it actually optimal or does it make sense for him to choose to do that activity? Well, he's missing out on additional benefits of 62 and only getting the additional benefits from going golfing of 36. So here, his net benefits would actually be negative. So that would, this is one where kind of his choice is inefficient, right? He's actually now in a world where once we factor in this opportunity cost, he has a kind of this net negative benefit from choosing activity. Whereas if he just would have chose to nap, right? Well, he valued that at 62. His next highest value activity he would have chosen to do is go golfing. So if he would have chosen to instead nap, he actually would have ended up with this positive benefit, right? So the setup of this one is a little goofy because this isn't a rational choice, right? He didn't choose the activity that he values the most, but giving, I'm telling you that instead he chose something that was inefficient, right? What would the opportunity cost then be? It'd be the marginal benefit or the additional benefit you would have got by choosing to do the thing that you valued the next highest, right? And here, the next highest would actually been the thing that you value highest, right? Because you value napping more than golfing, right? So to determine opportunity cost is what you could have done with your resources, what you could have done with your time that you aren't doing from whatever, or whatever activity you chose. Right? So here it goes golf. So the next highest value thing that he didn't do would have been taking a nap. So that's his opportunity cost. Questions on that one? It's a little bit, like I said, it's a little bit goofy because I chose the activity that actually wasn't valued the highest, but we can still analyze opportunity costs of every choice. Right?
It's not the difference between.
Nope. So I'm just right. I was kind of going into a longer discussion. There was a little bit more than what this question asks about net benefits, right? But here I'm just asking for the cost, right? So I'm just asking for that opportunity cost. And then if you wanted to think about the net benefits, it would be okay, have the benefit of golfing minus the opportunity cost.
So if he would have chosen napping.
Yep. Then what would his opportunity cost be if he chose napping? Well, the next highest value activity would be golfing. So his opportunity cost, if he went napping, would have actually been 36, right? So this is kind of like the scenario where if he would choose to go golfing, he gets this benefit. And his opportunity cost is whatever activity he would have valued the next highest. Well, in this case, if I choose napping, the next highest value is golfing. If I instead chose to go golfing, my marginal benefit is only $36, while the activity I'm not doing with that opportunity cost would have actually been 62. So it's always the kind of benefit of whatever the highest activity is that you're not doing. the highest benefit of whatever activity you're not doing. That's going to be your opportunity cost.
So it's just that value.
Yeah, yep.
So supposedly golfing would win $35, or would win $35, not 37.
Yeah. Any other questions kind of related to that one? All right, so going back to kind of this older idea of opportunity cost, let's think about this next one. So I've got a world where this individual is producing, oh, come on, two things, pants or hats. So we've got this kind of schedule, these different combinations that they can produce. I'm going to erase this. I was showing this as an example of what I'll give you on the exam. So don't have to have everything. I'll give it to you on Friday. So let's say I've got, you know, starting out, I'll kind of tell you a hint before we start writing them up. I can graph or kind of create this visual for the different combinations of hats and pants, right? Whatever these two goods are that the individual is producing. Now, what good I put on the x-axis, we go back and remember, whatever good I put on the x-axis, the slope tells me the cost of that good. So if I'm already seeing them ask for the opportunity cost or the cost of producing pants, then it probably makes sense to put pants on the x-axis. That way, when I calculate the slope, it'll tell me the cost of producing whatever good I put on the x-axis. Okay. So then I had, what was the other thing? Pants and hats, I guess. A lazy example. So if I'm only producing hats, how many hats can I produce? Yeah, so 120. I'm only producing pants. How many pants do I produce? So hats are 0. Pants are 4. And I could plot the rest of these points. I'll tell you right now, I'm going to, you know, the other combinations I gave you, we only ever looked at situations where we kind of had this straight kind of linear curve, right? I'm never going to have it kind of disjointed. And I'm just giving kind of one person's production possibilities or production possibilities frontier. So really important point is kind of plotting that point you'll be at on your X and Y axis. And then you kind of know that the production possibilities frontier is just going to be this line that runs in between two of them, right? If I start out in a world where I'm only producing hats, as I want to produce more pants, I have to transition my resources away from producing this Y-axis good of hats and use those resources to produce more of this X-axis good, right, or hats. Not hats, pants, sorry. Okay, so I can think about here, trying more specifically, right? I've got a quantity of hats in the Y-axis. So I said whatever good might be good to write down as you're studying, but whatever good you put on the X-axis, the slope tells you the cost of producing that X-axis good. So here, if I want to find the slope, I'm thinking about all I'm going to do is kind of rise over run, or the change in Y over the change in X. That's how you find the slope of a line. So if I go from this point to this point, what's the change in Y? I'm going from 120 to 0. So negative 120, you want to think about it that way, right? With downward sloping lines, the slope is always going to be negative. And then the run, or the change in X, I'm going from 0 to 40. So just 40 there, which should give me this slope of negative 3. So the opportunity cost for pants here would be that kind of slope of that production possibilities frontier, which, you know, it's negative because that's representing the cost to us. So if we're, you know, if it's phrased in terms of what is the cost, we would say it would be to produce one more unit of pants or one more quantity of pants. We had to give up 3 of the other good. So the cost of these 3 hats. If you want to think about it, we're kind of ignoring the negative sign because we already know this is going to reflect the cost. Any questions about how to come up with this, or what things change? Yeah. Yeah, if you want to think about it as like, if I asked you, what was the cost of your lunch? You wouldn't tell me it was negative $10. If right? Because if you're already saying it's a cost. So the slope is -3. The reason we ignore the negative sign is because we've already phrased it so as what is the cost, right? So, yeah, think about the lunch example, right? You wouldn't tell someone it was -10, it was -10. You would say that it would cost me $10. Yeah.
Would it matter if it was like 15 pair of pants or like 16 pair of pants? Like, does that matter?
So not for these examples we're looking at the production possibilities. We start to get to thinking about the marginal costs that are reflected on the supply curve, right? Which is different in this, right? This is just kind of telling us the different combinations of goods that we can produce in an economy. Once we transition to kind of the other topic, the other set of questions, which would be, thinking about the marginal cost of providing one unit from a producer, right? Then it will be a little bit different. Yeah. That's a good question. I have to kind of confuse this. Yeah, so here, because we have this nice linear production possibilities funds here, the cost of every unit would be the same. Other questions on this one? I'm not sure. Yeah, so, yeah. If you wanted to, right, you could actually take any 2 points in this line and you're going to come up with the same slope, right? Because I'm not having, right? In reality, production possibility curves are like this. So you're right, like in reality, we would have to do, but for us, we're kind of simplifying it. I'm always going to keep this linear. So yeah, you could take any 2 points. I just think that it's easiest to take these two because then the changes are obvious. If I'm going from 0 to 40, the change is 40, right? Prevents me from making some possible mental math errors or calculated errors. So 3 is really pretty redundant, right? So here I've got, if I wanted to graph this out in the previous problem, the slope of that production possibilities funds here tells me the cost of that x-axis. Now, problem 3 is saying, well, instead, what if you put hats on the x-axis? So if I instead put hats on the x-axis, now what's the slope of that production possibilities fund? Well, it doesn't really matter, but if I flip this around, what would the slope be? It's just the inverse of it, right? So if I know that 1 unit of pants, right, to produce 1 more pair of pants, I have to give up producing 3 hats. Well, then to produce 1 more hat, I would give up 1/3 of a pair of pants, right? So I can remember that whatever slope I find here, that's the cost of my x-axis good. But if I were to put the other good on the x-axis, where I'm interested in the cost of the other good, the opportunity cost of producing the other good, it would just be 1 over the cost of whatever that I have my x-axis was. Right? This would be the, I'll move out of the way in a second. The cost of y would just be 1 over the cost of whatever good I have my x-axis. Now I could just redraw this if I wanted to, if that's a little bit too confusing for me, right? All I would have to do is kind of put hats down here on my x-axis, pants up here, 40, 120. Now when I do rise over run, right, it's going from 40 to 0. It's going from 0 to 120. And sure enough, right, I get that. And the cost for 1 more hat would be 1/3 of a pair, or 1/3 of whatever good we have on the y-axis. What the questions are, so if you can remember that, the cost of your y-axis good is just 1 over the cost of your x-axis good. That's fine. And that if I were to put, hats here on the x-axis, everything would just be inverse. Or I could just redraw, right? But now my x-axis, instead of going to 40, goes all the way out to that 120 point. And instead of 120, goes to 40 on the, so I just flip those 2 goods, right? But I could redraw it and then just, okay, what's the cost of my x-axis good? It's just the slope of this line. Now when I find the slope of this line, it's -1/3. But notice that would be the same as doing the inverse of the previous cost. Any other questions on those? We'll kind of keep moving here. Okay. So what's the next? So let's say we've got one down here, right? I kind of graphed this one out for you. For one of the marginal costs of producing a pair of pants, or sorry, a pair of gloves, I switched my examples. So how would I do that? Based off what we just walked through, how would you approach problem 4 here? So you're looking for the cost of the y-axis good, right? So what would you do? Even if I don't not put numbers, but procedurally, how would you find that here? You would first find the rise over run, or the slope of that production possibilities frontier. That tells you the cost of your x-axis good. Right? So here it looks like it goes from 45 to 0, and then 0 to 15. So 45 over 15, or 3. Right? So 3 what? Well, 3 of whatever my y-axis good was, right? We're finding the cost of producing one more unit of our x-axis good. So to produce one more shovel, I have to give up 3 pairs of gloves for my production. Now that tells me the cost of producing an additional shovel, but I was asked for the cost of producing an additional glove. So once I have the cost of the x good, it's the inverse, or get the cost of that y good, just 1 over the cost of that. So the cost of one more pair of gloves would be 1/3. Right? Questions on that? Yeah, so we have this production possibilities. The problem is we know that the slope tells us the cost of the x-axis good. So here the slope of this line is going to tell us the cost of producing one more shovel. Well, we can calculate that slope by taking the rise over the run. So it goes from 45 to 0, so negative 45, and goes from 0 to 15 for the run. So negative 45 over 15. I guess technically to be complete, I should put a negative sign here, right? So I have the slope of this line is negative 3. And that tells me the cost of producing that x-axis good. However, I'll scroll down and go back. So the question asks for the cost of a pair of gloves, which is our y-axis good. What ends up being true is the cost of that y-axis good will always just be 1 over the cost of the x-axis good. So here that is 1/3. Right? We just take that old cost. Put it there. Any other questions on that? Some stuff I think that maybe it isn't on here because I know that it's relevant. So let me make sure what this next question is. Oh, actually, this one will be good. So I'm going to skip the word problem because I gave it to you kind of here. But if you had a word problem like this, even if I didn't give you this little table here, you could pick out, okay, Pat using all his resources can make what? 1,000 crusts per hour. So for pizza crusts, if Pat's using all his resources, he can produce 1,000. If he's using all his resources to make sauce, 200 gallons. And then we have another individual in this economy, and we kind of have, if they're using all their resources, how much they can produce of each good. So it's almost like both these individuals have their own production possibilities from here. Okay? So the first question is, okay, so what is Pat's opportunity cost of making one more pizza crust? And once again, whenever I'm looking for the cost of, it probably is easiest if I put that on my x-axis. Okay? So I'm looking for the cost of what? So I'm going to put that on my x-axis, which means the other good I could produce, which was all this sauce, goes on my y-axis. I can think of for each individual what this is going to look like. So for Pat, right, it's what? All of his resources, he could produce 1,000 pizza crusts, or if he's using all his resources, I'll try to draw this to scale, 200 gallons. We could actually just draw on the same graph. I'll grab a different color, but I'm not get my red marker. Oh no, it's over there. So for Jackie, right, it is 80 and what? 100 or 800 and 100? So 800, 100. We kind of have two production possibilities from this. So we were asked about Pat, which was this kind of blue line. So all we're going to do is find the slope of this line. So rise goes from 200 to 0. The run goes from 0 to 1,000. So the cost of a pizza crust is 0.2 or 1/5, right, of a gallon of sauce. So if we look at the answers here, right, and kind of anytime we have something like this, I'll give you like the fraction and the decimal, right? So 1/5 or 0.2 pounds of sauce is our cost. What if I instead had asked for Jackie's cost? What would that be? Once again, just the slope of that line. Hers instead goes from 100 to 0, and then 0 to 800. So -1.8. What is that? Is that 0.1 is 6 something? No. 0.125. I don't think I'm doing that. You correct it. Is that right? Okay. It didn't look right to me for some reason. So we've got our two costs, right? So who can produce this x-axis good for cheaper? These represent costs of the x-axis good. Who can produce this good cheaper? I can't remember the name of who represents who. The green person, right? I think this was Jack. I probably should have labeled this out. This was Jackie was the green line, and then we had Pat up there with the blue line. Okay. So we can determine the cost of either individual. Right? It doesn't matter what question I would have asked you, if I asked you for Pat's or asked you for Jackie's. But then a more interesting example or question might be, who has the comparative advantage or who has absolute advantage? So here, who has the comparative advantage in pizza crust production? Whoever can do it at a cheaper cost. So here, who has the comparative advantage in crust production? The lower cost was actually Jack, right? Negative, or 0.12 is less than 0.2. So we would say whoever has the lower cost has the comparative advantage. Now, go back. I also said that when it comes to just producing kind of two goods, we're kind of looking at these examples. If I have a comparative advantage in one thing, I automatically don't have the comparative advantage in producing the other good. So here, Jackie has the comparative advantage in crust production, which implies that Pat has the comparative advantage in producing sauce. Right? And the reason why that's true is because think about, here we've got, so cost of the crust, got cost of sauce, Jackie, Pat. So we just found the cost of crust for both of them. So Jackie's was 0.125, Pat's was 0.2. What would the cost of sauce be for both these individuals? We said if we want the cost of the y-axis good, we simply do 1 over the cost of the x-axis good. So automatically, when I do this kind of inverse, right, to find the cost of the y-axis good here, well, 1 over 1/8 makes that 8, and 1 over 1/5 kind of makes this 5. So kind of a law, just a byproduct of the laws of mathematics. Anytime I'm dealing with kind of these, anytime I take two values and I kind of invert them, those new values, like the equality sign, would switch, right? If I have 2 and 4, if I have 4 is larger than 2, but then 1 over 2 and 1 over 4, when I 1/4 is small. So if you have a comparative advantage in one good, you automatically will not have a comparative advantage in the other. So here we could use our old cost that we found to say that Jackie had comparative advantage in pizza crust production, which would then imply that Pat has a comparative advantage in sauce production. But if we remember this important idea, this principle that you can't have a comparative advantage in the production of both goods, then automatically we can rule out A and D as possible answers here. So, you know, even if I'm not sure I did this correct and I'm just taking a guess, it doesn't make sense. I can't have comparative advantage in the production of two goods, right? I can only have a comparative advantage in producing one of those goods. Questions on that? So essentially, comparative advantage, who can produce it at a lower cost? What if I ask about absolute advantages here? So what, instead, let's say I phrase this as who has the absolute advantage in pizza crust production and who has the absolute advantage in pizza sauce production? What would the answer be? So remember, comparative advantage was who can do it at a lower cost. Absolute, right, like kind of like an absolute truth, absolute advantage meant, well, I can just, if I was using all my resources, produce more than you. So here we would say, who has the absolute advantage in crust and sauce production? So if we look at this, if they're both using all their resources, who can produce more crust? They're using all their resources, who can produce more sauce? So this is kind of the idea we typically see with like countries where the US has an absolute advantage in producing a lot of things, right? We just use all of our resources to produce golf tees. We're going to be doing pretty well, right? The problem is by producing only golf tees, we're giving up, right? Producing these other things that we are really valuable, like my example is over ridiculous golf tees, but we keep producing, you know, higher level technology, we keep producing high level universities, right? All these things are kind of other goods that we want to put our resources in. So just because we have an absolute advantage doesn't mean we want to produce that good, right? Typically what we see is we end up usually producing goods where we have a comparative advantage. That's kind of the difference between absolute and then comparative. You can have an absolute advantage in producing both goods, but you'll only ever have a comparative advantage in producing one of those. Questions on that one before we can keep moving here before we have time. All right. So I want to kind of go through this one a little bit. Really just kind of get one key idea. So if we're thinking about instead, not just each individual's production possibility frontier, but we said in the economy, we start to kind of add those individuals, like kind of think about the economy-wide production possibilities. So we've got two individuals in our economy. And when it comes to a question like this, thinking about, okay, so I've still got the crust down here, and I'm going to keep sauce up here. If everyone in our economy is only producing sauce, how much would our economy produce? 300. What if our economy is only producing crusts? 1,800. So this question is probably a little bit harder than the one I would ask on the exam. All I want you to know is this key principle when you're creating an economy-wide production possibilities. You'll start, identifying these 2 points, right? If everyone in your economy is only producing that good, how much can you produce? And the other thing I want you to remember is then who's going to start producing that x-axis good first, right? Well, it's going to be whoever has the comparative advantage or the lowest cost. So we know that Jackie will initially start producing kind of crust. Like the very first unit, we're going to look at everyone in the economy who can do it at the cheapest cost. We have a two-person economy, Jackie can do it at the cheapest cost. So Jackie will start producing the first units of crust, this x-axis good. So we know initially the slope of our economy-wide production possibilities frontier will just be whatever Jackie's cost is. Now, eventually over time, we get to this point where Jackie has now used all of her resources to produce crusts. So if Jackie was only producing crust, right, she's used all of her resources, what would our quantity of crust be? 800, right? Once Jackie's producing 800 crusts, how many gallons of sauce has she given up producing? Yeah, from the original kind of starting point, right? We're now at 100 gallons. Or think about it this way. Now the only person in our economy who's producing sauce is Pat. So we're at whatever he can, the maximum. But being able to identify the point that you're at on your X and Y axis, and then identifying this point where your production possibilities frontier is then going to see a change in slope. Because now, if I want to get anything more than 800 crusts out of my economy, 2 people, now I have to start relying on Pat to produce that good. His cost was not much higher, but a little bit higher, right? So I then start to get a steeper curve. Right? And more general, if we have like an actual economy, it's going to almost look like this kind of nice continuous line, right? Where we initially rely on the people that can do it at the lowest cost, so it's a pretty flat line. But then over time, if we want more and more of this good, we have to rely on people who are less and less effective at producing it or have higher costs of producing it. But we can see that, and all those principles are kind of shown here in just a 2-person economy. Yeah. So if we think about, we've got 2 people in this economy. If they're only producing sauce, it would add up how much each one produces. Same kind of thing on the So on the exam, the kind of possibilities I give you when I ask you a question like this, like which ones would not be feasible, or essentially what combinations could I not get to? Right? Well, we know that the points up here, we would say are infeasible. They're outside of our production possibilities frontier. We said points down in here are inefficient. We're not using all of our resources. And then points on the curve, we said those were efficient points, right? So that might be, wink, wink, a good thing to know. There's several questions on the exam. Points on our production possibilities frontier are efficient. Outside are not feasible, right? We don't have enough resources to get there. And then points underneath the curve would be inefficient. We're not using all of our resources. Okay. So if I give you different combinations, what I'll likely do is kind of use these points, right? So some of these are a little bit harder, kind of like 900 and 195. But if I told you, 1,800, pizza crust and 0 sauce, well, that's an efficient point. That's actually on my production possibilities frontier. I might tell you, well, what if I was producing 200 units of sauce and 1,000 pizza crusts? Well, knowing that this point is 200, 800, if you plot that point, it's going to be somewhere out here. That's an infeasible point. Or maybe I would say something like 800 and 100, right? So if you plot that point, you can see, oh, that's inefficient, right? So instead of because I could really make it harder and I could choose like points out here, then you guys do a lot more math. I won't do that, and that's what a couple of the answers that are given here do. On the actual exam, these possible points I give you, you should be able to plot them using these 3 points as reference. Does that make sense? Is that clear? Not, it's fine if it's not. Explain it a different way. All right, so unlike this one in the practice exam, I will only kind of use values that you would see on either one of these. Now, I'm only using values. Like here I did 800 and 100, but just, I'll keep at least one of them the same so that making the graph, the graphing will be a lot easier, right? And you should be able to pretty easily, if you know that the point at which this will change is 200 and 800, right? Then if I have 800 and 100, I'm going to be at a point below. Questions on that? So, but really, on several questions, I might actually use something almost exactly like this, different numbers and probably different goods. But I might also ask you something like this. So know that inefficient are points underneath the curve, infeasible or not feasible, points past the curve, and efficient are points on the curve. Okay. Any questions on that one? We got 10 minutes. So what am I going to do with this time? We can go through some individual questions, but I'll kind of try to, unless there's a specific question someone has, I'll try to give you a little bit more of an idea of what to study, as opposed to working through individual problems, unless anyone has like strong opposition to that. Yeah. So if we're looking at this one, right, if we did 1200 and 100, 1200, 100, this would be one there. We have to do a little bit more work to figure out exactly where that's at, right? So that's one I wouldn't give you on the exam because that would be a harder point to determine if it's inefficient and feasible on the line. Another point that would be more realistic is for me to do something like 800 and 200. Well, you actually know that point is on the curve, it's efficient. So that can't be right because you're looking for the point that's what, not feasible. 900 and 195. If I go over here to 900, how much do I really have to give up? I have a point here, I have a point here. Once again, that's not a point I would give you on the exam. I would give you something like 900 and 200, which you know that point has to be outside of my frontier based off of knowledge about where this point. So if you're working through one like this, I wouldn't focus too much on this problem because it's probably harder than I would give you on the exam. Things I would give you on the exam would be numbers like instead of 900 and 195, 900 and 200. To make it a lot easier to know where those points are going to be at relative to that production possibility frontier. So I don't know what this is on the top of my head, but once you open, pull the answer key, you can kind of determine, or look at it. And if you want to really dive into it, right, you can determine, okay, well, now I know that the slope is -2. So if I want to get to 900, so if there's 100 additional units, I had to give up each unit of fit. So 100 times 0.2, 20. So I had to give up 20 sauce. So I actually know this point would be 180 and 900, right? Which means that the point of 195 and 900 is going to be like out here, but I'm not actually going to push you that far. So the one that we actually just did, that point's not feasible. So the answer, I guess, is D there. I chose the right one. So, yeah.
So basically most of these questions are like the questions that are going to be on the exam, except like 7.
I mean, they'll be similar. Yeah, I mean, there's a question similar to 7. I make it a little bit easier, but I just kind of point it out because I know that if you're studying through them, you would might get stuck on this. I don't know how to do that. I actually wouldn't push you quite as far as that question does. I make it a little bit easier. Another question here before I erase this. So the stuff that we just worked through would be really good to know, right? How to draw these production possibilities frontiers. Not that I'm going to the question's not going to ask you to draw them, but it just makes working through them easier, right? So know how to find costs, right? Know how to find costs from a production possibilities frontier. Know how to build one of those economy-wide production possibilities frontiers with 2 people. And then know the different ranges of inefficient, infeasible, and then efficient being on the line. From there, I would think about a really good thing to know how to do. Go back through. So we'll say costs from EPF is kind of the first thing I would make sure I know. The second thing I would say is the things that shift supply and demand. So these are things like if income goes up, we know that for normal goods, demand also increases, but for inferior goods, it would decrease. We know that if we have more consumers in our economy, right, we know that the demand curve in our economy, or the demand curve or whatever we're looking at, is also going to increase. If the input prices of something goes up, remember, supply reflects marginal costs, so if input prices go up, sorry, no, I'm going to do this. At every quantity, the new marginal cost is going to be higher. So input prices going up actually shifts our supply curve to the left or decreases our supply curve. So maybe go back to the slides where we're talking about what shifts supply and demand, kind of remember what those things are. You know, if I wanted to list them out here, so we do, you know, for demand, we had number of consumers, income, price of substitute goods, price of complementary goods. We could do fads, but I probably wouldn't use one like that in the exam. What else would I do here? Those are kind of the main ones. Probably forgetting one off the top of my head. Oh, we talked about expected prices, right? Kind of shifting current demand. For supply, we had number of producers, taxes, but really taxes were the same thing as increasing input prices. We also had technology, but that's really the same thing because it's just decreasing input prices. And then we also had for supply price expectations as well. So know those things that shift through supply curves and how they would shift through supply curves. And then under income here, as I kind of remind myself, we have normal and inferior goods, which just work a little bit different. So know the things that shift supply. I would say feel pretty comfortable drawing out a supply and demand curve and being able to draw that shift, because the next thing that we'll have to be able to know is how to identify equilibrium, right? Where supply and demand intersect, okay? But then from there, not only identifying the equilibrium, but how it changes from the shifts that we just talked about in supply and demand. We also went through some examples when it comes to equilibrium, right? We know this is where the definition is where quantity supplied is equal to quantity demanded, so the price at which that is true. But we also talked about we can do this with equations, right? So if I had, I don't know, my demand, my supply curves, know how to be able to use those to solve for what the equilibrium quantity and price are. I worked through an example in class like this. In fact, the example that I worked through wasn't too far in the past. We actually also use this to determine surplus value as well, right? But in terms of the equations, just not to use those equations to find your equilibrium. Also, kind of remember, when I'm thinking about my demand curve, what does this price reflect? Every time I draw supply and demand, what do I usually say? Demand is equal to what and supply is equal to what? Yeah, supply is marginal cost, demand is marginal benefit. So for my demand curve, that price actually reflects my marginal benefit. So if I plug in different quantities here, this is where the marginal benefit of different units can change. And then for supply, at different quantities, the marginal cost would be different, right? So for that first unit, my marginal cost would just be 5 plus 1 or 6. For the second unit, it would be 5 plus 2, so marginal cost would be 7. The third unit, here I chose an easy equation, so it just goes up by 1 every time. But kind of that's how we can determine the marginal benefit and marginal cost of different units using those supply and demand equations. Okay. We're kind of out of time here. Other things I would add on there, just real quick. And this is kind of the review that we did last class. Know how to do elasticities. And then also know how those different types of government regulation, price floors, price ceilings, taxes, and subsidies, know how they're going to kind of change surplus. So when it comes to these changes, know how to calculate what deadweight loss is, know where deadweight loss is, know how to identify producer and consumer surplus. I may not ask you to do a ton of calculations, but all of them would be fair game. Right? So some of the questions may ask you to calculate consumer surplus. Some of them may just ask, what happens? Does consumer surplus go up or down? Right? Those kind of ideas. So that would be kind of what I would lay out and knowing those topics. Obviously, we've talked about, I could break these down further and further, you know, but this is kind of the main general idea of what you should know going into that exam Friday. Okay. All right. So one more thing as you're leaving. My office hours again, apologize, are shifted today. So 2:50 to 3:50. I'll be in my office. I got called to another meeting I don't really want to go to. So that's what it is. I'll be very available tomorrow if you want to send me an email. Other than that, go enjoy the nice weather, maybe study outside today, okay? Yep.